Assalamualaikum and have a good day. My name is Muhammad Faisal bin Muhammad Rizwan. My mentoring number is B082010245. My supervisor name is TS Dr. Suraya binti Zainuddin, and my project title is Development of Software Application for Water Surface Monitoring using an FMCW radar. So for the project description, this research is about the development of software application for water surface monitoring using an FMCW radar, which or we call FMCW as a Frequency Modulated Continuous Wave, which design and implement a comprehensive software application for monitoring detection of a target at the water surface. For the introduction, this research is focusing on the development of water surface detection algorithm using an FMCW radar system, and it also by the algorithm itself we mentioned and we use a MATLAB software for algorithm development and validation through the experiments. We go to the problem statement. There are three problem statements here, which is the first one is the system ability to work well is limited because it's depend on just one radar to cover everything. And the second one is the presence of strong water spikes, particularly with a small size target, leads to target becoming nearly submerged in water clutter. And the third one is the phenomenon leads to a significant increased error during the target estimation process. For the objective also, we have 3 points, which is the development itself. To develop a water surface detection algorithm for FMCW radar signal processing by using a MATLAB. And the second one is the validation, to validate the range detection algorithm through the experimental data. And the third one is the last part of the objective we want to achieve is to analyze the software developed in terms of functionality and accuracy. So we go to the type of radar configuration. So there basically have a 3 basic configuration, which are monostatic, bistatic, and multi-state. For this research, we choose monostatic radar because the radar itself have arrangement where the transmitter and receiver are all in the same location and usually form the same piece of radar equipment, which is from the figure itself at the right side of the slide, we can see that we use one radar. So that one radar will transmit itself to the target, and then after the signal has been reflected at the target, it will receive back at the one that transmit radar itself. So for the type of radar configuration, the last point is this configuration allows the transmitter to be synchronized with the receiver, making it implementing the timing method for measuring the target range easier. So we go to the scope of the project. There's a 4 point of the scope of the project, which is to develop a water surface detection algorithm using MATLAB for processing FMCW radar signal. And then we go to the validate the range detection algorithm through the experiment data, ensuring its practical effectiveness. And the third one is to analyze the develop a software in terms of functionality and accuracy by meeting the predefined project objective and also the standard. And the last one is to implement the initial stage involving the target placement on water surface, followed by the data extraction and post-processing steps such as the fast Fourier transform, or we call that it as FFT. And the second last part, which is after we perform the FFT, we will find the peak detection, and also the last one is the range estimation. So for the methodology, we go to the process flow. So the first one, the first process is we'll configure the FMCW SO2 waveform transmit setting for distance to go, which is the radar module that we use, distance to go itself. Then it will transmit the bandwidth FMCW signal, which is it will transmit the signal from the radar station to the floating target itself, and then the signal will be reflected by the floating target. After that, we will receive the signal from the reflected target. After that, we will collect all the echoes reflected and we will filter. By then, we will mix the filter signal with the reference signal to produce a bit signal, which is the distance to go output is a bit signal. And then we will load the bit signal from the distance to go or the radar module itself in .tdd file, and we will transfer the data itself into the MATLAB. So after that, we will convert the signal to frequency spectrum by applying a far Fourier transform, the FFT. After that, we will use the spectrum peak detection to obtain the bit frequency. And after that, the last one is we will target the detecting processing for calculate the estimation range target, which is that is the objective one. So this is the illustration of the experiment setup, which is they have a laptop, which is the post-processing by using a MATLAB software, and then it will connect it to the RUT, radar under test, or we can say it's a radar module, and the radar module itself is the distance to go. So the height of the, by the way, the height of the radar itself will be 1 meter, and the distance is question mark, because we will do the estimation for the range, which is we will test from 2 meter until 9 meter, and the last part is the floating target. So right now is the field experiment for the view outdoor experiment setup, which is the height of the antenna is 1 meter, and then the RUT was connected to the laptop during the testing, and the last part is the floating object as a target object. So this is flow diagram for the real data experiment. The distance to go itself will we will take the output, which is the bit signal, the mix between the transmit and receive signal from the reflecting signal from the floating object, and then we will make the processing by fast Fourier transform algorithm, which is the code. All the code itself we have been made in the MATLAB, and then we will after the phase of fast Fourier transform algorithm, we will go to the peak detection algorithm. That's to find the peak max, and the last one is the range estimation. So this is the analysis from the data experiment. The range resolution itself is between the 2 meter until the 9 meter. So at the actual range, we put every of the estimation, the range resolution is 0.10 meter, because we want the radar itself can transmit, or we want the floating object itself in the area of the presence that the radar can detect. So the average, the estimation measure target range is 2.52, 3.04, 4.57, 5.33, 6.09, 7.548, and so on. So as we can see, the difference is slightly not so much. So as we consider, this project is successful based on the target, based on what we target, because we can slightly say that it's plus minus 0.50, but it still can consider it successful based on the data that we do and the algorithm that have been tested. So this is the graph. The blue color one is the actual target, and the orange one the average measured target. So as we can see, it's slightly different, not so much. So so we can consider this as a successful project. So this is the actual graph when the process of we find the peak detection, which is the resolution is 2, the actual range is 2.10, and then the graph itself, the peak detection, the right one is the frequency bit in hertz for the bit frequency for the first one, and the left side is bit frequency for the second one. So for the formula for the R estimation, we use the formula of FMCW, which is the range itself times the C. C is the speed of light. We will times to the frequency, which is the frequency 1 and frequency 2, and it will multiply with the time itself, and then it will divide it by 2 and the bandwidth, and then we will get the range estimation. So the formula itself I use from the FMCW range formula. So this is the analysis of signal noise SNR. They have a 3 stage of this noise that we use, which is negative 50, 0, and 50. So the reason why we use this SNR, we use the signal noise ratio, is because to get the accuracy, because the higher SNR, like 50 decibel, can lead to the clear signal and accurate the measurement, while the lower SNR, like negative 50 dB, it will cause the inaccuracy. So other than that, we use is for the algorithm performance. At high SNR, the algorithm detected signal well. At low SNR, it struggled to get the actual, or I mean like the range, it's a bit far. And for the testing, the difference SNR level from the negative 50 dB to the 50 dB, where you use test how well the code works under various certain of a noise condition. So this is the purpose why we do the SNR. So for the project potential for commercialization, we find out that this good use for the maritime navigation by enhancing the safety and efficiency. The second one is environmental monitoring by tracking the change in the water bodies. The third one is defense and surveillance and then we can do a monitoring of the maritime activities. And the last one is for the software licensing, to develop a software that can be licensed to industry needing by improve the radar signal processing. So for the conclusion of this project, that I can conclude is conducted the comprehensive analysis using simulation data and SNR experiment to assess the target detection code performance, by emphasize the importance of a noise control for optimal code performance through the XNR SNR experiment. And then, like I said, the project successfully, we get the range estimation that we want. So we successfully achieve the objective, which is analyze the software functionality and accuracy. And then we successfully develop a water surface detection algorithm for FMCW radar signal processing using a MATLAB. So that's all from me. Thank you so much.